In this session, we will solve systems of linear equations. When solving a system of equations, the goal is to find the point or points that solve all the equations at the same time. That is, we want to find the intersection of the system. And for any system, there are only three possibilities. There is either one solution or no solution, and the third possibility is to have infinitely many solutions. Two lines either intersect in a single point, or they're parallel lines, in which case they don't intersect at all, there is no solution. Or if they're the same line, then they have infinitely many points on a line. Methods of solving systems of equations. For the two-variable case, we have method of graphing. For example, solve the system x plus y equal 4 and 3x minus y equal 4. Well, to solve the system by graphing, you want to make a table to graph a line. And in particular, we can find the x and y intercepts. We call the first one L number 1 and the second L2. Then the graph x plus y equal 4. Well, when x is equal to 0, y is equal to 4. And when y is equal to 0, x is 4. So here's our coordinate system. Here's 0, 4. And here's 4, 0. And now we're going to draw the line passing through those 2 points. Here's the table of values for L2. And we plot the intercepts again. When x is equal to 0, y would be negative 4. And when y is equal to 0, x is 4/3. So down here is 0, negative 4. And 4/3 is 1 1/3. So there's 1 1/3 right about here. And now plotting the line going through those 2 points. And it looks like these two lines intersect in the point 2, 2. Now let's see if it solves each equation. Does 2 plus 2 equal 4? Yeah. And then checking the second one, 3 times 2 minus 2 equal 4. 6 minus 2 is equal to 4, yes. There's the intersection at 2, 2. A better method for solving the system is to use the method of substitution. And the reason why is that sometimes lines don't always intersect at nice whole number points. They might intersect at something like 11/17, 1/5. And it would be pretty hard to find that exact value. In the method of substitution, the idea is to take either equation and solve for one of the variables. It doesn't matter which one we decide to use to begin with, nor which variable we decide to start with, because at the point of intersection, the same x and the same y value for each equation. So that means if we take our system, x plus y equal to 4 and 3x minus y equal to 4, and take that first equation and solve for y, and we get y is 4 minus x. That value of y is going to solve the second equation. So we substitute into that second equation, and we get 3x minus y is equal to 4, and y was equal to 4 minus x. So the equation now is a 1 by 1, one equation and one unknown. We want to solve by usual method, distribution property, collecting like terms. We end up with 3x minus 4 plus x is equal to 4, because we want to use that distribution property on that minus sign. When we collect like terms, we see that 4x minus 4 is equal to 4. And now we want to add 4 to both sides. That tells us that 4x is equal to 8. And now at that stage, divide both sides by 4, and we end up with x is equal to 2. Now take this and find y by plugging it back into one of the original equations. And you can find the y value that goes along with that. So if we look at y was equal to 4 minus x, then y is equal to 2, because 4 minus 2 gives us 2. The point of intersection is 2, 2. An even better method is to use elimination, especially if we have equations involving 3 variables and 3 unknowns or higher. The idea in the elimination method is that you want to think about what happens when you add things that are opposite. They cancel out. That is your goal, to make things opposite. The first step in the elimination method is to decide what variable to eliminate. And again, it's not going to matter which one you decide to eliminate. You want to look at the equation and decide which variable is the easiest to eliminate. And then after you've done that, step 2 is to multiply by the appropriate factor. And sometimes you might have to say factors to make the variable cancel. So they need to be opposites of each other. And that's your goal, to make things opposite. X plus y is equal to 4, and 3x minus y is equal to 4. Well, if we decide to eliminate y, that would be the easiest choice, because the coefficients are already opposite. Take row 1 and add it to row 2, then we end up with is x plus y equal 4, and 3x minus y equal 4. And when we add them together, the y's drop out, and that was the goal, to make the y's eliminate. We have 8 on the right-hand side and 4x on the left-hand side. Now we have an equation. 4x is equal to 8, and now divide both sides by 4, and we end up with x equal 2 as a solution. We take that value of x and substitute it into one of the equations. And again, it doesn't matter which one. So 3 times 2 minus y is equal to 4. That tells us 6 minus y is equal to 4. So we get y is also 2. And we have our point of intersection, 2, 2. Let's do another example. Solve the system 2x plus 3y equal 5, and 3x minus 4y is negative 1. And let's choose to use the elimination method here. Now, in order to eliminate, the first step is what variable do we want to eliminate? And again, it doesn't matter. We want to end up with things that are opposite. So that means sometimes we have to find a common multiple of each other. If we decide to eliminate x, then we need to make the coefficients opposite of each other. So what is a common multiple between 2 and 3? And that common multiple, lowest common multiple, would be 6. We eliminate x by multiplying negative 3 times row number 1 and add it to 2 times row number 2. So negative 3 row 1 and 2 row 2. Well, negative 3 times 2x plus 3y equal to 5. Multiplying both sides by negative 3, we end up with negative 6x minus 9y is negative 15. And now 2 times row number 2, 2 times 3x minus 4y is equal to 2 times negative 1. And we end up with 6x minus 8y is negative 2. And now when we add these two equations together, the x's drop out, and that was our goal, to eliminate x. We end up with negative 17y on the left and negative 17 on the right-hand side. That tells us y is equal to positive 1, because when we divide both sides by negative 17, we end up with y equal 1. Now we take that value of y and plug it into one of the original equations. And it doesn't matter which one we plug it into, because we're finding that point of intersection, that point that lies on both lines. We have 2x plus 3 times y is equal to 5. That tells us 2x plus 3 is equal to 5. So 2x is equal to 2, so x is 1. And when we have a point of intersection, 1, 1.